Hi there, my name's Raz, and today we'll be looking at the reverse chain rule. Let's get cracking. So this is an extension of integration by recognition. It's been called the reverse chain rule in textbooks, so that's what I'm calling it. It's not really a terminology I grew up with. Funny enough, a student that I teach, shout out to Artin, he said, "Sir, what is the reverse chain rule? Can we do that?" I was thinking, I don't know what you're on about, boy. Surely it's just integration by substitution. So, but obviously they're given names for everything these days, so let's have a look at it. So if we do this by substitution first, I'm going to let u equal x squared plus 5. So we will get du by dx equals 2x. So dx is du over 2x. So if I rewrite the question, sorry, I've got the integral of x times u cubed times dx, which is du over 2x. So I'll get a cancellation, and that will become a half of the integral of u cubed du, and I can integrate that. So I'll get a half times u to the power 4 over 4. Yeah, which is 1/8 of u to the 4 plus c, and since u is x squared plus 5, the answer will be 1/8 x squared plus 5 to the power of 4 plus c. So this reverse chain rule is just us looking at the pattern and seeing, well, actually, if I make this substitution, this bit will cancel, and this bit will remain at the end. Yes, so this will remain, the x cancelled, and then we're just going to integrate as usual and add 1 to that power and divide by the new power. But we had to factor in the constant. Yeah, and that is the reverse chain rule. So there's not a huge need for it. You can just integrate by substitution, but this is a reverse chain rule lesson, so I'll stop squawking and just do it. So with the reverse chain rule, we've noticed that the answer must be x squared plus 5 to the power of 4 over 4 plus c. But there's a potential that we're going to have to multiply by a constant. Yeah, so in our head we can think, well, actually, this will differentiate to 2x, and once I get x over 2x, that will give me a half. So I'm going to times everything by a half. So I'll get 1/8 of x squared plus 5 to the power 4. So we got the same answer as before, but that would be using the reverse chain rule. So you don't have to do it. You could substitute. Personally, I would substitute. But this is a form of recognition, and we're recognizing what's in the rectangle at the top of the screen. So let's do another one, sorry. So if we substituted u equals sine x, it would differentiate to cos x. So there would be a cancellation of the cos, and this would integrate as normal. We do not have an extra constant to take into account. You can see that here. So it's simple. the answer will just be sine cubed over 3 times by that constant of 3 that's already there. Plus c, which will equal sine cubed x plus c. Again, so we did that with the reverse chain rule, but I will always have a look at this to just make sure I'm getting the constant right. Yeah, so the shortcoming of this technique is people aren't certain they've got the right answer. Yeah. You think you've got the right answer. You suspect you've got the right answer. You don't know you've got the right answer. If you want to know you've got it right, substitute. But again, this is a reverse chain rule lesson, so I should stop yapping about that. So if we look at this one, we're going to let u equal 2 plus cot x. So du by dx will be minus cos x squared x. Yeah, I think that's in the formula book. If not, you could always check it by using the quotient rule. You know that cot x will be cos over sine. So we could use the quotient rule to differentiate that, and we would suddenly get, that's u, that would be v, vu dash minus uv dashed all over v squared, and we'd end up with minus cos x squared x. Anywho, that's not what we're here for, so I'll stop going off on the tangent. So we have dx is going to be du over minus cos x squared x. So suddenly, there's a cancellation, but there's a minus sign that we have to be aware of. So we can rewrite the integral as the negative of the cos x will cancel, and we suddenly have u to the power of minus 3 du. Then we can integrate, we'll get minus u to the power of minus 2 over minus 2 plus c. So the answer will be a half u to the power of minus 2. So 2 plus cot x to the power of minus 2 plus c.